This is the introduction to the law of signs problems where you have an ambiguous case. This is still in section 6.1. In this case, this is when the given information they give you is side-side angle. And they say it in that order, side-side angle, meaning that the angle is non-included. All right, so, for example, let's say you have this situation. The triangle has angle A equal to 30 degrees. Side A measures 6 units and side C measures 8 units. I tried to draw a picture that was maybe a little bit to scale just so we could visualize what's going to happen in this problem. So A is 30 degrees and side C is 8. So that is going to be one of the sides of angle A. Here would be vertex B. Now the question is, where is vertex C? All right. We know that side A is equal to 6. The thing is, it could be drawn in potentially more than one place. Right? If you look at this triangle with a 30-degree angle in it, draw a perpendicular just temporarily and make a right triangle here. This is not going to be our actual triangle we're trying to find, but let's just make a right triangle. We'll put a right angle here. Since this is 30 degrees and the hypotenuse is 8, we can calculate how long this side would be, all right? This would be actually the height of the actual triangle ABC that we're trying to find. Now, you could use the sine of 30 degrees is equal to the opposite of the hypotenuse. 30 degrees is equal to h divided by 8, and solve that and get that h is going to be 8 times the sine of 30 degrees. You can also use formulas that you know about 30, 60, 90 triangles and figure out that this is the short leg and it is half of the hypotenuse. However you do it, h works out to be 4. So the height of this triangle would be 4. Okay, so what this shows us, since we have that's 8, that's 4, the side A that measures 6, it could be drawn in this direction here. We're going to extend and put the vertex C here, right? And then this side here would be little a, and that would be 6. Or we could draw a segment that measures 6 going that direction. So another possibility for A would be here, and then put vertex C there. So here's one possibility, here's another possibility, all right? That's just using the given information, all right? H, not really part of the problem, that's just trying to help you visualize it. But there are 2 triangles, ABC, that are possible with the given information because side, side, side is not a congruence postulate. So it doesn't guarantee that all angles with this given all triangles with this given information are congruent to each other. All right, now here's another possibility to just look at kind of intuitively. Let's say you're given angle A is 30 degrees, side A is 5, and side C is 50, all right? If you try to draw a sketch that's even approximately close to being to scale, you will see that this is an impossible situation. If angle A is 30 degrees, and this would be side C here with 50, very long, and then side A is 5, which is very short, there's no way you could draw in a segment that measured 5 units and have it reach this side over here. Okay, and complete a triangle. So sometimes the given information leads to no triangle at all. Okay, now we don't really want to work these problems out drawing them by hand. So let's look at how it's going to be when we work things out. First of all, when your given situation is side-side angle, there are 3 possibilities: that there will be no triangle at all, There might be one triangle, or there could possibly be two triangles. So that's how it is, 0, 1, or 2. And it really is all going to boil down when you're actually working the problem out with the law of sines. You're going to run into this kind of a situation very quickly, where you have to solve the sine of a missing angle is equal to some number. Right? Now, this will always just be a positive number. And when you go to solve a problem like this, there's two possible ways this could work out. If k is greater than 1, then there is no solution to the sine of b equals 1. And so there's no triangle. Right? If k is less than 1, then the equation that you'll be trying to solve will actually have two solutions. There will be a b sub 1 and a b sub 2. Right? And the way this will be is those two angles will actually be supplements of each other, meaning that they add up to 180 degrees. And one of them will be acute and the other one will be obtuse. Right? I usually just call B1, the first one that you find to be acute, and the second one to be obtuse. Right? So, for example, so you can kind of visualize how this might happen. Say you're trying to solve the sine of b is equal to 1/2. Right? There are two solutions to this problem. One of the solutions is 30 degrees. We know the sine of 30 degrees is equal to 1/2. And then the other solution is 150 degrees. Right? If you go back and look at reference triangles and you make a triangle that's 30 degrees, right, and the opposite is 1 unit and the hypotenuse is 2 units, that angle will be 30 degrees. Right? But also, if you are in quadrant 2, you can have the same scenario where the opposite of the reference angle is 1 and the hypotenuse is 2. Right? And so the reference angle also has a sine of 1/2. And this reference angle belongs to the angle of 150 degrees. Right? So, if you find one solution, the other one will be 180 degrees minus the first one. Okay. Now, what if it's not something like 1/2, which is a special angle, which most of the time is what you'll be dealing with? You'll have a problem like this, that the sine of your angle you're trying to find is equal to some decimal like 0.8. All right. This is less than 1, so this will have a solution. Right? And you will use your calculator and you will find the inverse sine or the arc sine value of 0.8. Remember, you use inverse trig functions when you're looking for the angle. Do make sure that you're in degrees on your calculator. You'll come up with that angle B is approximately 53.1 degrees, right? And that is acute. The calculator will always give you the acute possibility. And then you, to figure out the other one, you have to remember that it's the supplement of B sub 1. The calculator won't do this part. So you have to find the second angle by doing 180 minus the one the calculator gave you. So it's always 180 minus the calculator answer, which in this case would be 180 degrees minus 53.1. And that would give us a second possibility for B2. I'm sorry, second possibility for angle B. So B sub 2 would be 126.9 degrees. Right? Now, how do you know whether your triangle has one solution or two solutions? It will depend on this obtuse angle, whether it can be in a triangle with the original given angle. If the two of them together add up more than 180 degrees, then you can't have a triangle and it won't be an answer and you only have one triangle for your solution.